Hello, good day. My name is Osama Bueno, and I will be presenting DNA replication. So, this is a standard DNA diagram, where here you have your double helix strand, and then it separates into two strands, having a lagging strand and a leading strand. Now, topoisomerase is an enzyme that helps with the unwinding of the double helix of the DNA. So, in other words, topoisomerase, in other words, loosens up the glue that connects the two double helix bonds. And then you come to helicase. Helicase is a different enzyme that cuts the two double-stranded helix. So instead of, it's not a triangle shape like in the picture, but it does the same function. It opens up the two DNA strands to create the lagging and the leading strand. And then let's go into the leading strand, since this is the easiest one here. So our leading strand is goes from 5 prime to 3 prime, and the DNA polymerase, which makes DNA out of nucleotides, creates the replicated DNA from a 5 prime to 3 prime. It will go that way. That means that, so one important thing, I'm sorry, is that for any DNA polymerase to function, the strands must be going from 5 prime to 3 prime. That's how it goes. So here we have this example where it goes 5 prime and it runs this way, as you can see the arrow here, and it'll be adding nucleotides going this way. So it adds one nucleotide, moves over, one nucleotide, moves over, one nucleotide, and it keeps going until it's finished. And yes, so that's basically the lead strand. Since it's going in the perfect direction, 5 prime to 3 prime, then the DNA polymerase codes it perfectly. The problem is when it comes to the lagging strand. The lagging strand now, you need a DNA primase, DNA ligase, and DNA polymerase. So all these three functions help reproduce the DNA on the lagging strand. The reason why it's called lagging strand is because the DNA polymerase adds this new strand of DNA by combining Okazaki fragments, as you can see here, which are just little fragments of RNA that are copies of the DNA parent strand. So first, we have the DNA primase. So what is a DNA primase? The DNA primase is involved in the replication of DNA. So it is specifically an RNA polymerase that codes RNA segments called primers. And as you can see here, each nucleotide will be an RNA primer. And a group of nucleotides is a primer, I'm sorry. And then when these groups get joined together, they're called Okazaki fragments. Now, what is the DNA ligase? The DNA ligase then facilitates the joining of these DNA strands and changes the RNA to DNA. So it helps connect all the strands together. Once they are all connected and have changed from RNA to DNA, then they go into the DNA polymerase and create new DNA. And the reason why this one doesn't work the same as this one, the lagging doesn't work the same as the leading, is due to the fact that the lagging will go from a 3 prime to a 5 prime, and that's the opposite. And it's not able to code like that because it's going in the opposite direction. And this is your structure for DNA replication. Thank you.